everyone. Today we are starting Unit 2, and we are going to start with Section 9.2. This unit's a lot about polynomial functions, and today we're going to discuss their key features, okay? So right here, this is just the definition of a polynomial function, so you can look over that on your own. So example 1 right here, it says describe the key features of f of x equals negative 2 x to the third minus 3x squared plus 8x plus 3. So this is the graph over here off to the left. We are going to fill in this chart right here, which are all the key features that I want you guys practicing and getting familiar with of polynomial functions. So we can use this graph right here off to the left, but I'm also going to graph it on my calculator in a little bit just to kind of answer some of these questions and get more specific points, okay? So first of all, the domain. Remember, domain is left to right, so this is negative infinity to positive infinity. The range, again, goes from bottom to top, so I'm pointing down and then I'm pointing up, so negative to positive infinity. We've been doing a great job with domain and range so far. The end behavior, this is when you read as x goes to positive infinity, where does y go? And as x goes to negative infinity, oops, forgot the negative sign. Y goes to where? So as x goes to positive infinity, y goes to negative because it's pointing down. And as x goes to negative infinity, my y values go up, so y approaches positive infinity. Alrighty. X-Intercepts. So this is when I'm going to use my calculator because as you guys can see, the X-Intercepts, well, we know that this when the graph crosses the x-axis, okay? But those aren't nice pretty points, so let's graph this in our calculator. So go to your y equals screen. I already have it typed in. The main thing I want to point out is when you're typing in this equation though, make sure this is a negative sign right here. Okay, we don't want to use the minus sign. If you do, you're going to end up with a syntax error when you go to graph this. All right, let me make sure that's correct. Okay, graph it. That looks very similar to what I have right there. All right, so the X-Intercepts, we are going to hit second trace, that's the calc button, okay? And there's a bunch of different things in here, okay? Another word for X-Intercepts, remember, are roots and zeros, so I'm going to use this zero function right here to find those X-Intercepts. Now notice at the bottom of the calculator it says left bound, so that just means you need to be to the left of the X-Intercept. I'm going to go in order, so I'm going to go left to right for my X-Intercepts. So I need to go left of this point, and then I'm going to go to the right of it. And then it says guess. So I'm going to guess where it is, hit enter. So I have a 0 at x equals negative 2.754. Alrighty. All right, the next guy. Second trace, I've got 3 zeros here. All right, here's this 0, so I'm going to go to left bound, right bound, so go to the right of it. Guess. All right, x equals negative 0.341. Okay, let's see here, and we've got one more. So second trace, 0. This is where I think, whoopsies, that's where I think that guy is, so left, oops, to the right of it, guess, sometimes it's not going to be perfect, but it will take you back down there. So x equals 1.596, right, 1.596, yep, okay. Alrighty, now the y-intercepts, that's where the graph crosses the y-axis. This graph actually crosses it at a very nice point right there. So that y-intercept is y equals 3. Alrighty, the relative max and the relative min. We're going to come back to our calculator here. We should know that this is a min and this is a max. Again, those aren't pretty exact points, so let's use the calculator. Second trace, and would you look at that? There's maximum right there. So hit enter. Now this is left bound, so here's my maximum, okay? I have to go to the left of it, hit enter, now I gotta go to the right of it, hit enter, now I gotta guess, I think it's about there. Alrighty, so that is at let's see, 0.758, 6.470. That's going to round up if we go to 3 decimal places. 6.4. Oh wait, no, I can leave that 6.9. Oh, whoopsies. Sorry about that, guys. Six, 9. Yep, okay. All right, the relative minimum. So second trace, let's find the minimum here. It's all the way down here. All right, left bound, so go to the left of it, hit enter. Right bound, go to the right, hit enter. Guess, move my cursor there, hit enter. And the minimum is negative 1.758, comma, negative 9.469. Alrighty. And then the last part here, we need to find out when the function is increasing and when the function is decreasing. So we want to think of these on intervals, okay? So from here to this, or actually all the way down to here, the function would be decreasing, right? So that would be from negative infinity. I'm just going to read my graph from left to right and fill this in down here. So negative infinity all the way to this x value, which that's part of the minimum, so to negative 1.758. Okay, and then let's see, from here all the way to the maximum, the function is increasing. So from negative 1.758, the x value of the min, all the way to the x value of the max, the function is increasing. So the x value of the max, 0.758. Alrighty. And then from here all the way off to the right, the function's decreasing again. So I'm going to use my union sign. That means and, right? And that x value of the max was 0.758. And that's just going to, the x values go to positive infinity. Okay? So those are the key features. If I ask you for key features of a function, you're listing all this stuff. Alrighty. Now we are going to fill in this table below. Oops, why is my... Alright, fill in the table below by determining the following features of each polynomial without using a calculator. Okay, so we're done with the calculator now. Alright, the degree, that's just the exponent, guys. So 2. The leading coefficient, negative 1/2. Now the end behavior. We're going to start sketching these functions. So to get a better picture of this, remember, if you have a negative leading coefficient, that means the right side of your graph, so like over here, okay, that's going to determine which direction the graph points, depending on if your leading coefficient is positive or negative. So as x goes to positive infinity, so on the right side of my graph, my y values are going to go to negative infinity because my leading coefficient is negative, okay? Now as x goes to negative infinity, my y values are going to go, they're going to go the same direction as the right side because the degree is an even number. Even functions point in the same direction, so this will be negative infinity as well. Okay, maximum number of zeros. Well, this has a degree of 2, so that means I can cross my x-axis the most amount of times, 2 times. Remember, that's just the maximum. It's not asking for the exact amount. And then the maximum number of turning points, that means how many relative max and min you have. Well, if you think of it, if you can have 2 zeros, it's probably going to look something like this, right? So we need to, or you would only have 1 max or min, okay? So there's kind of like an idea. Now that's not the graph necessarily, but just to give you an idea. Alrighty, over here, the degree. Now we have to FOIL this out, okay? Distribute all this to figure this out. Well, we should know this is going to be x to the first. When I multiply, this is x minus 1 times x minus 1, which will give me an x squared. X plus 2 times x plus 2, that's going to give me another x squared. So then when I multiply all these x values together, that will give me a degree of 5, okay? Because remember, when you're multiplying exponential functions of the same base, you're just adding the exponents, okay? So know your exponent rules. From here, the leading coefficient, again, when I multiply all those x values, the number out in front will give you the leading coefficient, so that would just be a 1, okay? That is positive, so as x goes to positive infinity, because the leading coefficient is positive, that means the right side of my graph, remember we're focusing over here, is going to be pointing up. So we're going to positive infinity for the y values. And as x goes to negative infinity, this is an odd function, so that means that the y values are going to point in opposite directions. Remember, odd, opposite. So these y values are going to go towards negative infinity. Maximum number of turning points, of zeros would be 5. It just matches the degree. And then the maximum number of turning points now, well, if I have 5 roots, it's just going to be 1 less than it. So the maximum number I can have is 4. All right. We've got one more problem here on the back. All right. Without using a calculator, list the end behavior and the x and y intercepts of this function below. So let's see here. The end behavior, that's going to depend on the degree and the leading coefficient. Okay, that's how we found the end behavior on the other side. So remember, if I just multiply this all out, okay, I'm going to get x to the 1, 2, 3, 4, 5. That's going to give me x to the 5th, right? So that means I have a degree of 5. And then my leading coefficient, there's no number in front of those x values, it's just a 1. So the leading coefficient would be 1. All right, which means my end behavior is going to be as x approaches positive infinity, y is going to approach, the leading coefficient is positive, so the right side of my graph is going to point up. And then as x approaches negative infinity, y is going to approach, my degree is odd, so it's going to point in the opposite direction of the right side of the graph. Okay, so it will be negative infinity there. All right, and then we need to list the x and the y intercepts. So the x-intercepts are going to be, let's see here. Those are just going to be the roots of this function. So if I set these all equal to 0, I'm going to get -2. That's going to give me +2 when I solve for x, right? So x equals plus or minus 2. This will give me -5 and +5. Oops, does not look like a 5. Sorry, guys. And then this is going to give me -7. Alrighty. And then the y-intercept. All right, the y-intercept, remember, it's just going to be that last constant in this function. Now, one thing that a lot of students are going to try to do is that they like to multiply all the roots together. That's not necessarily right, though, because when you distribute all of this out, okay, that last constant is going to equal something differently than when you multiply the roots out, mainly because of the positive and negatives. It won't be the number-wise. It's just going to be, it might be positive, but you accidentally do the negative because one root ends up being negative. So we are basically just going to multiply these values. So 2, -2, 5, -5, and 7. So what's that going to be? That's -4. This is -25. So -4 times -25 is +100. Times 7 is 700. Now if you multiplied the roots, this is still going to give me -4 because I have a -2 and a +2. This is still going to give me -25 because I have a -5 and a +20, or yeah, -5 and a +5. So that's still going to equal 100 when you multiply all 4 of these together, right? But then if you multiply this by that root, which would be -7, you would have gotten -700, but realize that the answer is actually positive. That's what we just want to be careful of there, okay? Alrighty, and then you guys got your homework listed down here. It's 4 questions. Make sure you guys get that done and have a great day.